help you there. But I'll start by introducing myself and Cameron. So I'm Joel Seagren. I'm a director at the Passive House Association, and Cameron Munro is from Passive Analytics. So Cameron spent a fair bit of time in the kind of analytical space, and you might know him more recently from some of the work he's done around sensors, so particulate sensors and CO2 sensors, and particularly in a lot of passive house and some non-house passive house projects. So I thought, given it's a topical subject at the moment and Cameron's got a wealth of knowledge and data in that space, I thought what an ideal time to run a webinar on the topic. So I will hand across to Cameron, who'll do most of the speaking and slide control, and then I'll have a few little slides at the end there. But for now, I'll get Cameron to take it away.
Okay, thanks very much, Joel. Hope everyone can hear me okay, and hopefully you can see the slides as well. So bushfire smoke's obviously very topical for many of us across the country at the moment. Bushfire smoke is really just a form of particulate matter, or PM. PM consists of things like dust, bits of skin, mould, bacteria, cockroaches, mites, dust mites in your home, and we're exposed to it all the time. So, and it's fine stuff. And we often talk about PM10, PM2.5, and PM1. Now the numbers refer to the aerodynamic diameter of the particles. So a PM10 indicates particles of 10 micrometers, or 10 to the minus 6 meters, or less. And that includes things like PM2.5 and PM1. So think of it like a mesh. If you've got, say, a mesh that's got a 1 centimetre wide grid in it, then if you run stones through that, all of the stones 1 centimetre or less in diameter will get through. So you're capturing the finer particle matter as well. Generally speaking, we talk of stuff above about 2.5 microns as fairly coarse stuff. This is getting into the dust and the pollens. Then we've got the fine particulate matter below 2.5 microns down to perhaps around 0.1. And then the ultra-fine particle matter is the really tiny stuff of less than about 0.1 micron. And where this matters is in understanding what smoke really is and how it can get into our buildings. So smoke itself seemingly consists of 3 things that are all related, essentially different forms of carbon that get into the airstream and then ultimately percolate their way into our buildings. The critical factor here, I think, on this slide is really about the mobility diameter, or the aerodynamic diameter, the size of these particles, because this is what's going to matter when we talk about filtration. And the key point here is that these particles are generally very, very small, so somewhere in the range of 0.05 microns up to, well, 0.3. Some sources will tell you up to 1 microns. Now, much will obviously depend on the proximity that you are to the bushfire. The closer you are, obviously, you'll have more coarse matter, which will then tend to drop out as you get further and further from the fire itself. Now, I should also say that I'm no expert on this stuff, and so I've gone to some of the peer review literature and tried to understand it, and wherever I've taken something from that literature, I've tried to put a source down at the bottom here, so you're more than welcome if you want to contest my view on some of this to look at the literature and form your own interpretation of what's happening. So just to follow on the matter of the size of these smoke particles, this is a graph that was done about from some data about 20 years ago on a bushfire about 20 kilometres from the Brisbane CBD, where they tried to characterise the smoke by size composition. And the key point here again is that the vast majority of the smoke particles are very, very fine, less than 0.1 microns. Okay, so turning then to the question of the health evidence, and we've all probably been reading the newspapers and watching the news where there's been a lot of talk about the implications of our exposure to these levels of smoke. I've tried to split it here into two forms of evidence. So the toxicological evidence, which is cell studies that might be done in a petri dish or in simulation, through to exposing animals, rats, and dissecting them to examine how the cell structure, the blood, and the organs are functioning after exposure to smoke. And epidemiological evidence, which is population-level statistical analyses looking at the population of, for example, Canberra, and the rates at which there might be hospital admissions for various forms of health of conditions, which are seemingly correlated with higher levels of smoke. So on the toxicological side, there's good evidence to indicate that our bodies suffer from oxidative stress and inflammation when exposed to particulates, that the finer particle matter are not filtered by the throat and can pass deep into the lungs and ultimately dissolve into our bloodstreams. And this again is relevant when we consider the size of smoke particles. Interestingly, perhaps, that the particle surface area may be more strongly correlated with the inflammatory response than the mass of the particles. And this is relevant because we usually measure the concentrations of particulates as a mass, the density of particles, rather than the count of particles or the number of particles. And if you've got a huge amount of very tiny particles, there might be a lot of particles, but they might not have a lot of mass, but they do have a lot of surface area. And then fourthly, the particle composition may be important. And this is particularly relevant, I think, in an urban context, where for most of us, most of the time, most of the particulate matter to which we're exposed is either internally generated in our buildings from combustion, from our gas cooktops, from just cooking full stop, because as soon as you do a fry up, you're getting lots of particulates into the air. And then in our urban environments, from all the combustion from our motor vehicles going around, from factories, from vehicles, not just from the combustion process, but also from brake pad wear, from tyre wear, and then of course the asphalt roads as well. So the actual materials in the particulates are also seemingly important, but there's a lot that seems to be still fairly poorly understood. On the epidemiological side, there's a dose-response relationship. The higher the particulate matter, the higher the hospital admissions for various conditions. And similarly, when particulate matter concentrations decrease, you see a decreased admission rate for these conditions. And predominantly these are sensitive subpopulations, those with pre-existing conditions, the elderly and children. So there remains the question of what happens over a comparatively short period of exposure among the healthy population. Are these leading to prolonged or morbidity or mortality health issues? So the thing that's perhaps not been fully understood yet is how the short-term exposures that we've been experiencing, be they at very high levels, are going to have some near-term or longer-term consequences for our health. Turning now to bushfire smoke specifically, there was some relevant epidemiological evidence from some Sydney research that was done over a period of about 15 years looking at bushfire events, and they were associated with an increase in hospital admissions for respiratory conditions by about 6%, chronic pulmonary disease admissions by about 13%, and asthma by 12%. Interestingly, the average PM2.5 ranges that were in that analysis were up to around 100 micrograms per cubic metre. Some of the concentrations we've seen are 3 or 4 times that over the last 3 or 4 months. So we're talking about a very significant event. Some other studies have similarly indicated a strong association between smoke exposures and respiratory morbidity and all-cause mortality, as well as some mixed evidence on cardiovascular conditions. So there seems to be fairly strong evidence that this is clearly not doing us any good, and that we ought to be seeking to minimise exposure to bushfire smoke. All right, but we're all passive house people, so the real question is a passive house going to help us avoid these sorts of events? And obviously a building is going to get PM infiltration through the building envelope itself and through the ventilation system. And there's a number of studies that have looked at these infiltration factors. So the ratio of outdoor particulate matter that reaches indoors, and have found that generally speaking, on average, just over half, or about 0.55, is the ratio of that outdoor PM that makes its way into the building. So if you think of you're getting some deposition of that PM as it moves in through the building fabric, as it settles in your wall cavity, on your window sills and so have you. And so that makes sense in the context that we're being advised to stay indoors during these smoke events, because the particulate matter concentrations indoor, so assuming you're not creating a lot of indoor PM sources yourself, ought to be lower than those outdoors. Now, with passive house, of course, we're very interested in extreme levels of air tightness. And so we would probably want to argue that the level of infiltration ought to be significantly or much lower in a passive house. There doesn't seem to be a lot of evidence to support that. This is one study from some apartment blocks in South Korea, none of which were mechanically ventilated. So all of the PM sources we are going to have to assume have come in through the building envelope somehow. And there is some, at best, weak evidence that at the very tight levels of air tightness are we seeing a decrease in the infiltration factors. And just to point out, of course, that the ACH 50 is not necessarily a good indicator of the level of infiltration that might be going on in practice, given the environmental conditions at the time. So this doesn't really provide us with the strong support for our argument that if you want to avoid smoke infiltration, you've got to build super tight of itself. Now here's some data. Recently, this one's actually my place in Melbourne. So some of the smoke events over January. So the blue line is the PM 2.5 concentrations outdoors, and we've got 3 very significant peak events that you can see there, and then 2 locations indoors, a bedroom that obviously has a supply duct for the mechanical ventilation, and the kitchen with the return. And we can see that the indoor PM levels are indeed tracking the outdoor levels, although the peaks are somewhat lower, so that is a relatively good sign. But critically, the PM levels indoors are still well and truly exceeding the healthy thresholds. And the healthy thresholds that are recommended for PM2.5 is 25 micrograms per cubic metre, averaged over a 24-hour period. And particularly on the highest peak period you can see here, that has been significantly exceeded. Now this is not a passive house, I'll emphasise that. It's 1.2 ACH, but it's mechanically ventilated with a standard F7 filter, and it's clearly fairly tight compared to this standard Australian buildings. What about turning to a fully certified passive house then? So this is actually Harley's place up in Canberra, the first certified passive house in Australia. Extremely tight, 0.1 ACH. So we're not going to get much tighter than that, with an F7 filter again on mechanical ventilation. And yet again, we're seeing the levels of particulate matter indoors well and truly exceeding healthy levels, although the peaks indoors are again significantly lower than those outdoors. So this is a glass half full kind of situation in a way. We're doing better than being outdoors, but we're not maintaining healthy indoor air quality just by building a conventional passive house. So there's some other things we can do during at least short-term smoke events. So one obvious thing would be to turn off the mechanical ventilation system if that's contributing to the particulate infiltration. And so this is a test where I tried to do that at my place, again emphasising that we're not quite as tight as passive house. And in the morning turned off the the ventilation system and left it off until the evening. And the red line here is outdoors. And unfortunately, of course, the PM levels don't stay stable over time, so it's a bit of a hard one. But I've drawn a couple of lines there and suggested, well, the gradient or the rate of change of the outdoor particulate levels here are increasing over the day and possibly increasing at a lower rate indoors. So that's obviously only the infiltration through the building envelope, but it's a fairly weak sort of a relationship, and because the PM levels are continuing to increase indoors, and we weren't really generating any indoor PM on that day except perhaps a bit of walking around, which does stir up some stuff, it doesn't seem that that of itself will be sufficient, certainly not in a building of this level of air tightness, to avoid these events. And of course it comes with consequences in terms of indoor air quality. I think that by the end of this day, with 3 occupants, we were up to about 1,500 parts CO2, so that wasn't going to be an acceptable long-term solution to these sorts of events. So the next thing that we tried in our case was to put an F9 filter. So the higher numbers, as Joel will talk to shortly, of the filters indicates a higher level of filtration, so it should capture some of the finer material. Here I've put an F9 filter on the supply run upstream of the mechanical ventilation, which is not really what you ought to do, but it was easy to do for what was in effect a $10 car air conditioning filter to see what effect that would have. Now unfortunately I did this at a time when the outdoor PM levels were actually decreasing, and so what I would have hoped to see here is that if that F9 filter were successfully removing a lot of that incoming smoke, then over that day I should see those indoor PM levels decrease relative to outdoors, but they're not. They're really just tracking with the outdoor levels. So that suggests, I think, that the F9 filter was not an adequate means of filtering out the smoke. Alright, so turning back to the air tightness question again. So we've argued that a passive house and a near passive house can reduce the peaks in the PM relative to outdoors, but not necessarily reduce it to healthy levels. What about a conventional dwelling? Are we doing better than a standard home? So in this case, again, the blue line represents the outdoor particulate condition over a period of 48 hours or so. Then I've got a yellow line being a bedroom, the green being the kitchen in my home, what I'm going to call a near passive house, so again 1.2 ACH, and the peaks here are hitting sort of maybe half to 2/3 of the outdoor value. And then we've got the living room in the red of the building next door, which is a conventional double brick leaky sieve with no mechanical ventilation, and the peaks there in the red are much more closely tracking the outdoor peaks than they are in the near passive house. So what I think we would argue here is that the combination of air tightness plus the mechanical ventilation providing some level of filtration is providing a superior level of air quality than would be achieved in a conventional dwelling. So that's the positive slant on this sort of data, but again emphasising that we are well and truly beyond healthy levels of particulate matter in this building. Here's another example, again a building in the blue that's got mechanical ventilation, an F7 filter, all the usual air tightness. It's not quite passive house, I think it's in the order of mid-1s ACH, but it's pretty tight compared to a standard dwelling that was about 600 metres away. And again, you can see particularly on that peak there to the right that the standard dwelling has had a PM2.5 concentrations well beyond 400, which is extraordinary, as opposed to the passive house or mechanically ventilated dwelling are around 200 parts. So it's more than half the peak particulate matter concentrations. And that's consistent across the peaks that you can see there. So there is a somewhat good news story here. Alright, this bucket is courtesy of Harley's great efforts in Canberra to to try and deal with these situations. So this again is a 0.1 ACH dwelling, so it's about as tight as you'll ever get. And he's run a bit of a home modification with a HEPA filter, which is a very high grade filter. These are the things that are generally used in hospitals, and run it downstream of the F7 filter that's on the mechanical ventilation unit to try and provide some additional filtration of that smoke. So does this help? Well, the data would suggest that indeed it does. This is a great test case because we've got in Harley's case, we've got two dwellings that are essentially identical, located next door to one another, both 0.1 ACH, both mechanically ventilated certified passive houses. Fantastic. One of which has got a HEPA filter, one of which has not. And the difference is stark. So the blue here represents the outdoor particulate levels. The red is the standard passive house with just the F7 filter, and then the yellow is with the HEPA filter in line as well. And we can see that the HEPA is doing pretty much what it says on the tin and bringing the particulate levels back down to within the healthy range. The only exceptions being periods of internally generated particulate sources, the cooking spikes that you can see there, and also a period there where there was some night purging going on at the start where the windows were open to cool the building. So that's a pretty positive thing, but of course, as Joel will mention shortly, installing a HEPA filter does have consequences, and it's probably not something we want to be doing permanently. This is then another iteration on this. So what if we were decide that we wanted to have a HEPA grade level of filtration but not run it in line with our mechanical ventilation system? So this is a conventional off-the-shelf air purifier in a standard dwelling, run it for about 8 hours overnight, and again the particulate matter levels here are decreasing overnight. Now unfortunately I don't have the equivalent levels outside at this time, so there's always a question of whether the outdoor levels were also decreasing. But there is good evidence out there, there's plenty of papers out there that indicate that air purifiers, when sized appropriately to the size of the dwelling, will effectively reduce the PM levels. And I imagine the other argument we could make from a passive house point of view is that the level of infiltration across the building envelope is so markedly reduced that arguably we might be able to size for a smaller purifier, but conversely, you are maintaining a constant level of infiltration across the mechanical ventilation system, which is likely to be your weak point. Okay, Joel, so I'll hand over to you.
Beautiful, thanks Cameron. So, just thinking about smoke again, and we'll get back to that slide. Obviously, smoke has got some particulate matter that Cam's talked about, but it's also got odour, and odour is a bit of an interesting thing. So, odour is a molecule that can be bonded with some of the particles, and if that's the case, there's a good chance of trapping that with some particulate type filters, so the F7, F9 and HEPA type filters. But it can also be gaseous phase, meaning that even though we do some particulate filtering, we're not going to capture that. So the way you might then tackle that is with some activated carbon or equivalent. There's some other proprietary mixes that allow you to capture that odour. And as that diagram shows, you'd only ever want to do that after you've done some particulate filter. So you can see on the left-hand side the contaminated air. That runs through some filtration levels before hitting the activated carbon. If you choose not to do the pre-filtering, you're basically going to bomb and saturate your activated carbon with all sorts of gunk, and it'll be dead in a very short period of time. Noting that activated carbon, like the other filters, are also consumable, i.e. they need to be replaced depending on the loading you put on them, either fairly quickly or some period anyway. So Interesting, yeah, that there's two components to that. There's the odour and the particulate stuff. So particulate stuff is what can do the damage to us from a health perspective. Odour is more the discomfort factor, but both are being raised as obviously as issues at the moment. Can you jump down a slide for me, Cam? So practical implementation solutions. Cameron's given us a good bit of background on what seems to be making an effect and what's not. If we look now at filter efficiencies, we can see the yellow line there's our standard sort of passive house minimum grade for passive house projects, being an F7, and that's shown in yellow, it's line 3. And if we have a look up around about that PM 2.5 level, which is sort of the bigger particles, we should be getting a really high efficiency there. But as Cameron's shown in that distribution of smoke particles, we're finding that stuff is actually a lot smaller than the PM 2.5. And so as we track back to the left-hand side of that chart, we're seeing, for example, that an F7 filter at about 0.3 micron particle size has really only got about a 50% efficiency. So no surprise that those smaller particles are getting through easily. If we step up to look at F9, and again, Cameron showed some data for that, but on this chart, it's the blue line, line number 1. We can see efficiencies are improved, but they're actually still falling fairly rapidly as we get into that smaller particulate range. So it's really not, that filter improvement, as Cameron showed, is really not an improvement, and the data's aligning pretty well with, or not a sufficient improvement. The data's aligning pretty well with the theory and data around filter efficiency. So, and here's interestingly what happens when you get into the smaller particles. So this would sit onto the left-hand side of that chart we're looking, but as we get right down to those 0.1 micron stuff, we see a little bit of a dip and some rise again there. So what it's basically saying is, hey, look, the filtration level from anything in the F range is not that great. And you really, if you're looking to capture that small stuff, you're really up in the H range, so the sort of HEPA range, and you can see H11 right at the top there. Jumping on to the next slide, it's really just a look here at how you might go about practically installing some of these improvements. Now, F7, as we mentioned, is a fairly standard supply for passive house grade ventilation systems. F9 seems to be an option for some systems, potentially not all systems, but some ability to integrate that. Now, as we said, it's not a full solution, but if we just looked at how you might at least improve your filtration, there's a couple of options there. Noting it's always important that you start with your course of filtration. So if you look at the dotted line on the left-hand diagram, the black dotted line with an arrow, it's essentially showing the pathway of the supply air into your building. So it's important we're getting it across the F7 filter before we get to an F9 filter. On the left-hand diagram, you'll also notice the integration of a carbon filter that's got potential there. Now, these obviously aren't our full solutions in terms of getting a really good filtration and a HEPA grade filtration, but it is typical of what you might find in the market being available at the moment. To my knowledge, HEPA as a standard addition to HRV systems is not really available. It would be a little bit of a bespoke addition. On the right-hand side diagram there, the difference really is that rather than sort of getting the F9 filter at the sort of manifold or back at the unit level, we've actually got it out at the supply grill level. And so one of the potentials for this sort of application is that you could short-term retrofit something of these types, and you might even be a chance of getting something a little bit better than F9 as a bespoke solution. But as Cam said, it's not really a full solution if you're looking to take out all those really small particles. If we drop down to the next slide, it's really a bit of a summary about what should we do in terms of filtration for passive houses. So obviously we've talked about the improvement in smoke particles in odour. from better filtration, and we've seen that F9 is probably really not quite enough if we want to knock those out, and that we certainly need to add some carbon filtration if we want a complete solution that's going to take out odour as well. The evidence of health impacts from these small short-term exposures to less than sub 2 micron particles, Cam's presented some good stuff there. It's still a little bit unclear what that short-term impact is on a healthy human being. Obviously, for those with compromised health, it's a different case, but we're really making comments about average healthy humans here. The downsides of going for some additional filtration are obviously some capital costs, and I'd expect adding an additional filter housing and so forth is going to set you back $300 without much trouble in your system setup. You've got some increased filter change costs. So instead of being sort of at that 65 to 85 for a set of F7s, you might be up around a couple of $100, and they could last you, depending on your outside environment, at a maximum of 6 months, I'd suggest, probably less than that. Increased HRV power consumption. So these filters that are finer are obviously requiring a fair bit more fan power to drive the same volume of air through there. And given the systems haven't really been designed for retrofit of HEPA sort of grade filters, unless you put an extremely large filter and surface area on there, you're going to significantly drive up your fan power consumption. And that additionally is going to give you some increased noise level from your HRV unit. And in terms of power consumption, it could be substantial. You could go from what's typically probably around 40 watts for an average house ventilation in terms of HRV power consumption. You could be up in excess of 100 watts running through a HEPA filter. So it's really, if it was something you're going to do, it would really want to be a removable short-term retrofit option or short-term use option, where when we get elevated smoke levels from bushfires, you could put something in there, remove it out for normal use. Hopefully the level of bushfire smoke we've seen this summer is not a regular occurrence. It's interesting, when we were in China listening to the International Passive House Conference, that PHI specialists, so Passive House Institute specialists, weren't recommending, and again to their local Chinese market, that they run HEPA type filters. And I think that view was a little bit about the power consumption, but also infiltration paths through front doors and things like that. So interesting commentary from there. As we've said, temporary retrofitting is probably a better possibility. Cameron also touched on the use of indoor air purifiers, and we probably need to see a little bit tighter data around that with regard to what outside levels were like, but potential, particularly in a passive house where your infiltration's low, that might do the job for you. And the argument for increased filtration where your building air tightness is low is pretty weak. So for passive houses, there's definitely something in that space. But for some sort of passive house, then really the infiltration is going to overwhelm anything you've got going on there. So that's all we've got in the way of slides for you. I can see a few messages coming through. So Cam, if you've got yourself unmuted, I will read out some questions. So the first one, HEPA filters come in different grades. What grade is it, please? So I think, Harley, you might be on the line if you wanted to unmute yourself and make a comment on what grade HEPA filter you'd trialled there. Yeah, okay. I'll take a bit of a punt whilst Harley gets himself unmoved. Typically, they're going to be a H11 or a H13. That's a typical sort of HEPA filter there.
I think you can hear me now.
Go for it, Harley.
Yeah, so that HEPA filter I've got there, it's like a $30 fake Dyson filter. So I was a bit dubious as to what it said it was. I think it was like an 11. I think it starts with a U11 or something.
Okay. Yep.
But it was a dodgy one from Amazon, $30. But geez, it works. It works. So yeah. So HEPA filters are like 11, 12, and 13 grade. So I think it's just an 11.
Yep. Beautiful. Thanks, Harley. Next question, does the home with the HEPA filter also have the F7 filter or just the standard MVHR filter? If you're there still, Harley, you're welcome to put that comment in.
Sure, yep. So I've got my normal F7 filter, and then the HEPA filter is added afterwards, like downstream. So just as Joel drew on his diagram, I've got the outside air hitting the normal Zender F7 filter, then going through the Zender HRV, and then on the output, it goes through my homemade bucket HEPA filter, and then it goes into the manifold and then into the rooms. So both filtration levels at the same time.
Beautiful, yeah, and that's the way you obviously want to do it. If you put your fine grade stuff before your F7 filter, you'll have it blocked in no time. So it's always the case that you need to work from coarse through to fine. Makes sense. So just a question around bypassing. So bypassing should still run through your filters. So whether your HRV unit's in bypass mode or not, that supply airstream should still be coming through your filters. So it shouldn't make any difference. Can we get a copy of the slides? Lots of good info. Yeah, we'll make a copy of the slides available. We will also, as I mentioned, we've also recorded the webinar, so we will make that available in some manner. Any other comments, Cameron, whilst we just see if there's any more questions come through?
Only a thought that for those that are interested in the quality of the sensor data here, there's a couple of slides that I've added to the version that we'll put on the APHA website that indicate that the sensors do seem to be tracking reasonably well with the EPA or the Air Quality Authority data, the proper data in our various states. So the data seems to be in the plausible range. So I think we can make reasonable conclusions from the data that we've got here.
Yeah. So another question, Cameron, and you might have some data to support this. Is there any evidence that pulling air through outdoor landscaping, so trees, shrubs, etc., might help with particulate matter? Anything you've seen there, Cameron, that might support that?
It's a bit like the argument about putting indoor plants inside, isn't it? To help out VOCs and so on. I don't know. I'm only going to speculate on that. I think the fine nature of this matter is probably not going to. The presence of vegetation is not going to make much effect. Just as the evidence seems to be pretty weak for the usefulness of indoor plants in addressing VOCs and so on. I don't have any evidence to say that.
Yep. Any reason why we shouldn't use air purifiers inside a passive house instead of modifying the ventilation system? So good question. I guess we need a little bit more data on the air purifier, and we'd need to understand size and ability to treat different rooms. I guess one of the advantages of HRV type systems is it's distributed throughout your building already. So air purifiers you may need multiple versions of them or move it around or something like that. Obviously some capital costs there as well. And as I say, a physical thing inside your house that's occupying some space may be an aesthetic issue for you, but certainly something worth trying. I don't know what the costs are. Cameron, any idea what costs might be for something like that?
Yeah, I think Ben will be able to speak to the cost of his units, but you see them online for sort of $300 to $500, and presumably on the street in Canberra right now $5,000. But yeah, they seem to be that sort of several $100 range. And there is, although that graph that I showed there with that purification unit from Ben's place is suggestive of an effect. There are a number of studies out there where they've purified in buildings and demonstrated that, again, if sized appropriately, they can have the desired effect. So that does seem to be an alternative way of achieving what we're trying to achieve.
Yeah, and Ben's dropped some.
I was
going to say, Ben's dropped some comments in there sort of saying 300 to 500 for small units. Ben, do you want to unmute yourself and just elaborate on that? Is that a unit that does sort of just a room or something more than that?
There we go. Is that okay? I've got 2 units that have a clean air delivery rate of about 95 cubic metres per hour, which is quite a small unit. And I have 2 of them, and we just use them just for sort of just for purifying bedrooms at night primarily. What I was just had in mind with my question was, in theory, if we can get the purification loads down small enough, we can actually purify a passive house with a relatively small unit.
Yeah, certainly. Do you feel they need to be used in multiples, or you can use a single unit and move it around the house?
Well, in my house, I need multiple units for sure. It really remains to be seen. Like, maybe we should take my purifier down to Harley's house.
Mm-hmm. Are they noisy, Ben?
No. So the article I read in Choice suggested that you deliberately oversize your unit so that when you run it at the required ventilation or clean air rate, that it's typically operating on medium. And so we can sleep quite easily with them on medium. Yep.
I guess the other thing also is that there seems to be 2 sorts of operating control of these things. One is just pushing the air through a HEPA filter, which I assume is what you got there, and then the other one is these ion generators that move the ion onto the oxygen molecule and supposedly it's participate that way, but then generates ozone as a byproduct.
Yep. So yeah, my units do both, and I only use warmer.
Another question saying, is there a good solution for a temporary HEPA filter addition for buildings or HRV units? And the answer is probably not really at this stage. I'm not aware of anything that is a semi-standard application. It's certainly something we can explore a little bit more. The real challenge for HEPA is obviously to get big surface areas so we don't get huge pressure drops. But it's something we can have a little look at. Going forward.
And it does seem, Joel, based on Harley's data there with his bespoke cheap as chips solution, that these things are demonstrably effective.
Correct. The data seems to support the quality of filtration. So it's just about the application and what the cost might be for something like that. Any other questions that people have got? I think we've run through most of the list there. Someone's mentioned Wirecutter has a good review article on air purifiers. I'm guessing that's a website. Gives you some background. Someone's asking about the energy impost of the HEPA filter. If you're there, Harley, are you able to give us some guidance? I had heard by Cameron that you were pretty much running your unit flat out in order to deliver the airflows whilst the HEPA was in line. Is that correct?
Yeah. So I measured all the airflow through the house before I installed it, and the fan was running at 65% and chewing through 25 watts. And after I put the HEPA filter in, to get the same airflows, I had to increase that one fan to 100%. But I did measure the wattage, but look, it's probably going to be like, from 25, say doubling it to 100 watts. Say, I don't know, is that a fair estimate? Sorry, 25 doubling would be like 50 to 60 watts. So yeah, in terms of in the scheme of things, an extra couple of light bulbs of power, it's probably worth it to get a good night's sleep.
Yeah, it'd be interesting to get a measure on that, Harley? I'm not sure whether you've got a watt meter or something you can
I do.
in line there.
I do, and I will take that measurement, and I'll email you if you can circulate it, just so that people know. But yeah, the machine at 100%, it wouldn't pull that much, but I'll do a measurement.
I reckon it'll be I reckon it'll be a surprisingly large amount. If you look at sort of fan laws, it should increase with about the cube of the change in flow rate or fan speed. So I'm gonna put my money up near 100 watts or more. But it'd be great to see, Harley, if you can post some stuff.
Okay.
Sorry, Harley. I was just going to ask, running the unit at 100%, are you noticing a noise in your bedrooms at night?
No, next to the machine, it's a bit louder because it's not just the fans that are running. It's the airflow through that bucket. It's not really aerodynamic. So it is a little bit noisy in the laundry, but I don't live in the laundry. But in the bedrooms, it's not noticeably louder. No, it's not. I wouldn't. No one's lost any sleep over the noise.
Okay.
You can hear a bit more. It's like having it. I mean, it's louder than having it on boost, but it's not loud enough that it will annoy people.
Okay. Yeah, I just noticed in putting the F9 inline on our unit and boosting the fan speed, you could perceptibly notice the difference in the noise in the bedroom, but it wasn't drastically bad.
Yep, exactly.
Beautiful. Any further questions from people? If not, we'll draw the session to a close. As I mentioned, we'll make the slides available. I think Rachel, our APHA admin, will have all your email addresses, so we can make some copies there. Or alternatively, if you're an APHA member, we might have an extended pack that you can download from the website. Nothing more seems to have come through in the way of questions. So thank you all for your attendance. Great to have a nice big audience today, and sounds like we've hit a good topical subject matter. So if you've got subject matter that you really